Hi, I'm Anne-Marie Imafidon and I'm CEO and Head Stemette at Stemettes.
And I'm Carla Rosario. And this is Stemettes Say What? A brand new podcast brought to you by Stemettes.
In each episode, I'll be joined by a co-host, today's is Carla, and guest to discuss what it's really like to break into the field of STEM.
Being an academic is like juggling lots and lots of different projects while someone's pelting you with snowballs or something like it. There's a lot to manage. And I guess you learn on the job. It's like a slow ramp up.
This week's guest is Johanna Vos, and she'll be answering our 4 whats on academic careers.
We'll discuss the 3 parts of an academic career, planets, and dealing with rejection.
Hello, Johanna. How are you?
I'm great. I'm so happy to be here.
Yeah, I'm excited to have you on. I want to take you back to the moment you fell in love with STEM. What was that like for you?
There wasn't a moment. Like when I was a kid, I just liked science. I kind of got it. I've always been very poor at memorizing things. So it meant that in science subjects where you don't have to memorize things so much, there's like a method. If I tried to think of like a moment where I decided I am going to pursue science as a career, it would be the very first time I saw the Milky Way. I grew up in Dublin, which is a city with lots of light pollution. It's also very cloudy, even if there wasn't that much light pollution. You know, you can't see the Milky Way from Dublin. I was in California for a summer with my friends near Lake Tahoe, middle of nowhere, completely dark skies. And I saw the Milky Way for the first time. And I was like, wow, made me want to know more about the universe. And I think that was a moment where I was like, okay, I'm going to pursue this.
I wasn't expecting you to have such a romantic response. Wow, it's like a movie.
It's a romantic response. I'm wondering, I don't think I've ever seen the Milky Way. So I feel like maybe if I saw the Milky Way, maybe I'd want to go into science. I'm laughing a little bit also, sorry, Johanna, to be laughing at you, at the memory thing, because that was always my anti-science thing. There's too many element numbers or whatever. And I was like, maths is very methodical. Let me just stick here because there's nothing to memorize. But you're right, there's less to memorize than like, I don't know, history or whatever. But one thing that I'm hoping is not hard for you to remember is what you do at the moment. So can you tell us a little bit about your journey from the Milky Way to your position in academia at the moment, and maybe a little bit about what a typical day looks like for you?
When I saw the Milky Way, I was doing a degree at like the university close to me in Trinity College. I had no idea what I wanted to do like for my undergrad because I loved science, but I also loved English. I still love reading novels and all of that. I was very mixed up, but I ended up in this very broad degree. It was called Natural Sciences. So you didn't have to decide day one, I'm doing this. But I saw the Milky Way and I thought, okay, I finally found something I can specialize in. So I specialized in astronomy and astrophysics. Towards the end of my undergrad degree, we got to do like a long-term project. It was a 10-week research project. I was so lucky I got to go observing. I went to a telescope in the Canary Islands on top of a mountain in the middle of nowhere and saw the Milky Way every single night for 2 weeks. And I observed the sun, actually. I was doing a project in solar physics. And I enjoyed that so much that I thought, I think I'll pursue this a bit further. And I went to do a PhD. And at this point, I knew I wanted to do a PhD in astronomy. But once you're in astronomy, I'm sure it sounds like a very small field. Once you're in it, you realize there's so many different types of astronomy you can do. You can be doing solar physics where you look at the sun. You can be doing exoplanets where you look at planets beyond the solar system. You can study black holes. There's lots of different things. But I just decided to find a supervisor that I liked. I just met this really, really cool astronomer who works at the University of Edinburgh. And she took me in and I did my PhD with her on exoplanets. So looking at planets beyond the solar system, understanding what's in their atmospheres. And a PhD it's another 4 years at university, but it is quite different. There's no classes, there's no lectures. It's you doing a project with your supervisor. At the end of those 4 years, you write a massive book, you defend it in front of other astrophysicists, and then they say, you passed, you're a doctor of astrophysics, and then you have your PhD. After that, I was so lucky to get my dream job, which is in the Department of Astrophysics at the American Museum of Natural History. It's just on Central Park West. We have huge planetarium. We also have dinosaurs. We have gems and fossils. It's really nice to be, surrounded by all sorts of science every day.
I'm imagining you in Central Park now. Like, if your typical day, that's what it sounds like the beginning of a movie. You're so Hollywood, Johanna.
Everything's so cool.
That's so funny because I couldn't believe I was walking up the steps at the museum to go to work or like walking through Central Park. But yet day to day is very varied. And my research is I'm an observational astronomer. So I take data from telescopes in space, like the James Webb Space Telescope that was just launched, telescopes on the ground. I take data onto my computer. I write computer codes to analyze it. I look at the results. I write papers. I give talks. I do lots of teaching. I do lots of outreach where I share my research with the public. I like the variety, definitely.
That sounds so exciting because I guess maybe it's a bit naive, but I kind of thought that career in academia meant you're just like, obviously you still do interesting research, but I didn't imagine it could be so fun and cool. It sounds really cool.
Yeah, and I think I thought it would be really isolating before I started it. I don't know if I ever thought I would still be here. Yeah, it's a lot more lively and there's so many people involved. You get to work on huge teams, which I like.
Cool. Well, I feel like we've already touched on it a bit, but should we get into our first what? What one of this episode is what type of research do you do?
I'm an observational astronomer, which I just said, which means I work with data from telescopes. I'll get time on a telescope like the James Webb Space Telescope, the Hubble Space Telescope. And there's also telescopes on Earth as well, like the Very Large Telescope is a hilarious name for one of the telescopes that we use. They're building the biggest telescope ever. It's going to have a mirror of about 35 meters across, and they're calling it the Extremely Large Telescope.
I thought you were going to say they're calling it the biggest one ever. And I was like, that's a funny another name. And now it's just called the Extraordinary Large One. Y'all are focusing too much on the research and not enough on the naming of the telescopes.
I know, it's dreadful. I think we need to just like hire people to do that creative thinking for us because we're not capable. But anyway, I use all of these telescopes to look at weather on planets beyond our solar system. If you look in the night sky, you'll see stars all around you. Pretty much all of those stars have at least one planet orbiting. And my job is to look at those planets and try to figure out what's going on in their atmosphere. So we can find clouds in their atmosphere, aurora in their atmosphere. We can measure the winds in their atmosphere. So all the weather things on Earth, like we're trying to find it on other planets.
How do you decide which planet? Because it's so funny because you started off and you're like, astronomy sounds really big. And then it's like, we've zoomed in and then it's like exoplanets and then it's all the other planets. And actually, it's still quite broad on a day-to-day basis. You don't have the PhD looming over you. And so for anyone listening in, how does one decide on their field of research? But even more so, like how much freedom do you have over the topics that you research at the moment or the planets that you choose or the field that you're in?
That's like really one of the things I love about my job. It's that I really come up with the research questions that I want to answer, that I'm interested in. And I really do have complete control over what I decide to do. The only caveat with this complete freedom thing is that often we have to kind of convince people to let us do it, if that makes sense. So if I want to use one of these amazing telescopes in space, we have to write a short proposal. And it's really like a sales pitch. It's like, give me 10 hours on this telescope and I will tell you what's going on in the atmosphere of this planet. And this is why it's important. So sometimes getting the resources to do the projects we want to do can be tough, but we really do get to decide what we're doing.
There's two flip sides, isn't it? It's like, it's great to have your own autonomy over what you're doing and stuff. But then I guess being your own boss, like how do you work out how much time you're going to dedicate to stuff? Or do you have deadlines that you set for yourself? How do you kind of shape your life?
Being an academic is like juggling lots and lots of different projects while someone's pelting you with snowballs or something. There's a lot to manage. And I guess you learn on the job. It's like a slow ramp up. So I guess in my PhD, I was very much focused on my thesis. And now I'm a bit more independent, or people need my expertise on their projects and I'm pulling people into my projects. And I've just learned to be very, very organized with my time. My calendar has to tell me everything that I'm going to do.
I think memorizing a calendar is also, sucks a lot. I laughed as well at something you said about being like, give me an hour of this telescope and then this can happen. And I promise you. And it's like, you can't really make a promise of what you'll find because the idea is it's research, right?
You know that meme that you see on Instagram and it's like expectation versus reality? That is so apt in academic research. Like, I've promised the moon and the stars in these proposals. And then, there's something wrong with the data, or the planet wasn't as bright as you thought it would be. Or if it's a ground-based proposal, it might be cloudy and you might get nothing. You can guess what the weather is like or what's going to happen. But yeah, it doesn't always work out exactly how you expect. So we're all quite flexible and there's a lot of problem solving when things don't go the way we planned them. Just like brainstorming, like, what can we still say about this object? Like, maybe we can't do what we said we would do, but we can kind of pivot and do something else.
Cool. So I feel like that leads quite nicely into our next what.
Which I think I wanted to zoom out because we asked earlier, what does a typical day look like? I think you've mentioned juggling lots of different bits. So can we zoom out maybe a little bit from just one typical day and think about maybe a quarter or a year?
I guess when you think of like what we have to do over the course of a year, you can kind of split those into 3 sections. One is research, and that is maybe what you imagine when you think of an academic. For me, it's getting data from telescopes, writing papers, going to conferences. For other scientists, it could be like in a lab doing the actual experiments and then writing papers. The second thing that we often have to do is teaching. We all do a lot of teaching in some shape or form, whether it's normal lecturing in a university, like during my PhD, I did a lot of that, like in a university setting. It can also be like right now, I advise a lot of students at both high school level and undergraduate level. So I do research projects with students to get them into like the process of conducting research. And then the third thing is called service. That can encompass a lot of different things, but it's often what we call peer review. So say, Anne-Marie, if you publish a paper, it might get sent to me and then I read it and tell you what you need to change about it before it can be published. You could also peer review telescope proposals. Like, I could be the person deciding who gets to use this amazing telescope this semester or this year. And it can also be like outreachy things. So like at the museum, I get so many opportunities to just like speak with members of the public. I get lots of school groups coming in, and that would all kind of fall under that like academic service that we all do.
I was just thinking about the peer review bit, how like you also get to look at proposals and stuff instead of like one big boss deciding like where all the budget goes. Does research feel like quite a collaborative community?
Definitely. And different scientists work in different ways. Like, I think some people genuinely like working on their own. And if you want to do that, you can. But I personally think like the best science is done when you pull together lots of different people with different expertise, different experiences. And so those are kind of the projects I'm more drawn to, where I'm working with lots of people. I mentioned the James Webb Space Telescope. We just published 2 papers using data from that telescope. The very first directly imaged exoplanet observed with the telescope and the very first spectrum ever observed with the telescope. And both of those papers had like 110 authors on it, which is a lot of people working together. And we just all worked over the summer together. And then on a more normal project, I might be working with 10 to 20 people on a project. It is a very social thing. It gets such a bad name, doesn't it? You're probably surprised that I'm always like in conference calls with people and coming up with ideas together. I feel like a lot of people don't realize that about science.
Yeah, that's so cool. It must feel like such a group achievement as well to publish. It must be such a good moment. Do you have
Yeah.
like publishing parties where you celebrate?
We do. We actually do. For the big ones, I've had a few.
Do you get to travel with your job? Like, do you ever go in person and like meet with people?
We get to travel a lot for various different things. Because I use telescopes, I get the chance to travel to telescopes quite a bit. So during my PhD, especially, I was using this one particular telescope in Chile. Every 6 months, I'd fly into like the middle of the Atacama Desert, go up a hill to this observatory called the Sia Observatory. I'd spend like a week or two there observing, and there'd be kind of like me and like 10 other astronomers there, staying up all night, sleeping all day. It was really, really fun. So there's like observing trips, but then there's also conferences. I've been to lots of conferences, really fun conferences all over the world. I was at one conference where we got to see a total solar eclipse on the first day of the conference, which was really cool. It's like a bonding experience. And then there's just like research trips. Like if I have travel money from some funding, I could like go and work with my collaborator for a week. So just this summer, I spent 2 weeks in Santa Cruz working on a project with my collaborators.
Kind of another question I think people would be quite interested. What is the pay like in academic careers?
I will say, like, none of us are doing this just for the money. Like, it's not paying us a lot of money. If I was someone who really prioritized money ahead of all else, I probably would not be in academia. But it's worth it for me to do a job that I love. I've always been paid enough to have a nice life. And a lot of people don't know, and this is why I like coming on podcasts like this and talking about PhDs. A lot of people don't know that like you get paid during a PhD. It is a job. You're being paid to do that. So I think it puts a lot of people off doing a PhD because they're like, I can't stay in college still. Like I need a job.
Whereas, I didn't know that.
Yeah, a lot of people don't.
Didn't know that.
I think it's an interesting one considering that pay, because I wonder. So I mean, I've got another hat on, I should say. I'm not pretending, but I'm on council of Research England here in England, and they're the ones that allocate all the funding for kind of research that goes on across the higher education institutions across England. And it's definitely something we've looked into a little bit about whether people know that, again, you can be paid and there is funding, but also what the access is like to that funding. So I think it's one thing to get to know that funding's available, but I think the other thing is it's really competitive, right? To be able to get funding, get enough funding. There are a lot of folks who end up getting their stipend but still have to work to kind of top it up. So I know it's definitely something, appreciate you saying, Johanna, that it's something that, you're not doing it for the money, you're doing it for the love of the research or the exploration, or, that freedom to explore what you want to explore. But I know it's definitely something that folks are trying to work on to make sure that it is accessible, I guess, for folks to be able to do and to be able to afford to do their PhDs at least. I know postdocs and the rest of it, you can negotiate a little bit differently. But yeah, for that research and PhD, and I think it's really important. I wanted to ask you a little bit more about the difference, because you're based at a museum. And again, if we think of Hollywood, or I don't know, if we think of academics, normally you imagine the person at a university, and you've mentioned already, you've got the research bit, you've got the teaching bit, you've got the service bit. Who knows that, you can do that academic role in different spaces that aren't just a higher education institution. So I wanted to ask, what do you think is the difference between your role being based at a museum and your experience as an academic versus any of your friends or ex-colleagues or peers who are academics inside a university? Is there a difference at all?
Working at the museum has been a really great opportunity. Being in this different environment means that these three parts of my job, service, teaching, and research, are a little bit different. And specifically with teaching during my PhD, when I thought of teaching, I just thought of, standing in the front of a lecture hall, giving slides, which is fine. We all did it. But then I come to the museum and teaching takes on all of these other different things and like a whole range of people. It's not just undergrads who have signed up to do astronomy. It's like members of the public who wander in. It's kids who are excited about astronomy. Or often it's kids who are like dragged to the museum by their teachers and they have no choice. And we're always trying to like reach those kids too. You don't have to have a passion. I didn't have a passion for astronomy until I was in my 20s, I would say, until I was at university. So it's kind of like learning how to teach different people, to communicate with different people. And we have lots of different teaching techniques. Like we At the museum, we have a huge planetarium called the Hayden Planetarium. I don't know if you've ever been in one. It's like being inside a cinema, but it's kind of like all over the roof in a dome.
With the lights on the ceilings. I see them. That's another one. It's like,
Yeah.
I don't know if I've seen in a UK planetarium. I don't think you see them in the movies, right? They always take people there on dates.
Yeah.
Right? That's like a thing.
Yeah, there's definitely an episode of Friends where they're like in the planetarium.
Where Ross,
Yeah. Like, it's amazing that we have that, right? We can literally load real data into the planetarium and we can fly people around the Milky Way and show them what the universe is. You know, it doesn't have to be slides.
Oh,
Yeah.
I need
So
to write that down. That's got to be on my bucket list now.
I feel so lucky.
I think it's great to be able to observe the difference. And I've never heard it broken down as that research teaching service. And I think it is a nice way to kind of think there are different ways to teach, and it does overlap quite a lot with the service. And so it's nice to be able to kind of conceptualize that and think about it. And I think the idea of service drives so many people that being able to do that as an academic, you know, we should be talking about that a little bit more. So third, what? Let's talk skills. We talk a lot about STEM skills at Stemettes and giving people STEM knowledge. Skills as an academic, you know, we talk about industry, we talk about entrepreneurship, academia. What kind of skills do folks need to do those three pillars, but also to thrive in academic careers? Maybe let's go, I don't know if we call them hard skills. We call them hard skills or core skills, I guess, at Stemettes, rather than hard and soft, although I know the opposite of hard is soft. But, you know, what kind of like hard skills? What are research skills? What are the STEM skills, I guess, if anything, that folks need to be able to thrive as academics?
There's so many different skills that would really help you. And I think this is why I like working with lots of different people. We're not all great at all of these skills I'm about to mention, but it's like creating a team where you hit all of the skills.
Small
is
disclaimer.
Like perfect. Yeah. It's like
you need like 4 out of 10, not 10 out of 10.
Yeah. No one's perfect. Or like, you know, some of us prefer some part of research to other parts. But yeah, I would say like hard skills would be for my line of research as well, which is kind of computational. So like coding, coming up with experiments from start to finish. Like there's a lot of planning that goes into that. Thinking analytically and logically, thinking through things from start to finish. Like when I write a proposal, I am thinking of what I hope will happen, but I am also thinking of what will happen if it doesn't work out. Like when I was in secondary school and I really loved English, and I was like, well, what am I going to do with English if I wanted to go into science? But a lot of my job is writing. I spend days writing proposals, writing papers, coming up with talks that are not just boring science talks. Like I try to entertain people when I give a science talk. Writing, communication, presentation skills are all really useful. I actually think, and I think this is maybe a surprise to a lot of people, I think the skill I most value in a scientist would be creativity, because the best papers I've written or the best papers I've ever seen have always just been a really creative or innovative idea, right? You just try to come up with something no one's ever done before to try and solve a problem we're all trying to solve. So if you can think outside the box, that is the best skill you can have as a scientist. And all of the other skills you'll figure out, like how to code, how to do whatever maths you have to do to get to that problem. That's really the best skill that I'm always trying to work on myself anyway. And then as you get a bit more senior, you have to start leading a group and like planning what everyone is doing and motivating everyone in a group at all times.
I mean, you've already kind of touched on it, but that's kind of one of the core skills. Of being able to talk to people, and I guess like setting expectations when you're writing your proposals and doing your speeches and stuff. That's all stuff which I wouldn't have initially thought would be like super important, but it seems that way.
Yeah. And, you know, before I went into science, I thought scientists are probably not very social people. Like that's the view of a scientist we always get. If you can't work with people, then you're probably not going to get that much science done, you know? You go to conferences to meet people, to come up with ideas.
Carla was classically trained in art. There's like this fun fact that I always end up repeating. I feel like I say this at least twice a day on various calls and to various people, but you're much more likely to win a Nobel Prize in the sciences if you've engaged with the arts as part of your upbringing. And I'll say it again, you're much more likely to win a Nobel Prize in the sciences if you've engaged with the arts as part of your upbringing. So I think it is definitely something of folks being able to have that like cross-disciplinary approach, like bringing other things in and mixing them together. And I guess, Carla, it makes you an even better Stemette, right?
Yeah. That's the idea. I studied fine art for a year before I came to study. I'd now do computer science. That has been invaluable in making me kind of a better student, a better person in terms of how I evaluate my work and think about problem solving. I mean, I think everybody should take some time to get creative.
And you've just reminded me, in my research group, we have an artist in residence, and they mainly do poetry. And every so often they'll read us a piece of poetry they write. And it's about our work, but just in a way we've never thought about. We're in the nitty gritty, like we're thinking spreadsheets and computer codes. And then they'll write us this poem and we'll be like, oh, yeah, that's what we're doing. Or this is why we're doing this work.
That's so cool that you've got a poet on your team.
We're very lucky.
I want that. I want someone to
that.
just like write poetry about my life and tell it to me.
Yeah.
So what skills do employers look for in prospective academics?
I think the single most important thing is that you have some sort of research experience during your undergrad. That can take many forms. Like you can be really lucky. Maybe in your university, there's a professor who might take you on for a summer. Or like, for instance, I was really lucky. My undergrad included this 10-week research project. But also there are lots of citizen science projects out there. I work with a particular one called Backyard Worlds, where regular people in their homes help us look for new worlds inside and outside our solar system. That is just normal people doing research. You don't have to be a complete whiz with computer programming. So just like some experience of, being involved in a research project in some way, I think is an amazing thing to have on your CV.
It's about the passion, I guess, then. Just showing that wider interest. I think it's time for our fourth what, which is basically, what is the career progression like within academia?
Generally, after your undergrad, you'll go into either a master's or a PhD. Masters are not always necessary, but sometimes are necessary. That'll take you about 4 years to complete. Then you move on to looking for the job I have, which is like a postdoctoral research position. And that's when like a new group will probably hire you. Moving in academia is very common. So I moved from Edinburgh to New York City to work with this new group. And at this point, you can also start winning fellowships and grants. It's kind of like you just win a lot of money to just pay yourself for the next 4 years to do this research project that you've written down, which is really amazing. So those people are truly independent researchers and they can bring it wherever they want. And typically these days, people will do 1 or 2 postdocs. That's the job I have. So often people move every kind of 2 or 3 years to a new position. That can often be anywhere in the world. Sometimes it's exciting. Like I'm very lucky. I've lived in amazing places like Edinburgh and New York. But it can also be kind of a bad part of the job where, you settle down, especially somewhere like New York. It can take you a year to settle in. So if I had left a year later, it would have been quite stressful. But after maybe 1 or 2 postdocs, that's when you start trying to get a permanent job as a professor. Or there are these research institutes that hire permanent research staff. And in that case, you probably have less teaching to do, and you would devote more of your time to research. There really aren't that many of these kind of permanent professor jobs. We're all in these subfields and everyone's getting more and more specialized. So the step from postdoc to a permanent job can be really, it can be really, really hard. And that is something to consider before you pursue this academic path. If it doesn't work out, would you be happy with that? Because this permanent job definitely is not guaranteed.
I think it's definitely something that folks kind of have to weigh up, right? Like you're saying, coming into this space, we call it kind of precarity or precariousness of it all sometimes. And it is that kind of short term. I mean, I know we've got another episode where we talk about freelancing, and I mean that's also right, just as like unsure and uncertain, and so you do have to keep your eyes and ears open and peeled for those funding opportunities, for those different places that you can be an academic, and also for kind of give yourself space for failure. I mean, I don't know, I wonder if that's anything that you've dealt with throughout your career. You said you've stayed longer in this postdoc. There might be another one coming next. You know, who knows what's next for you, but how do you bounce back when those rejections and, you know, the next step that you thought was going to be a step doesn't happen?
So that is something we deal with a lot in academia, like rejection. You know, I'll put in 10 proposals and I'll be lucky if one is accepted. We're just constantly writing proposals, and there's so many astronomers in the world, and we all would use the same telescopes, or we all want to get the same funding source from NASA. You can't always win it. It takes getting used to. I think for me, just like learning from my mentors, you just have to believe in yourself. And when you start off as a PhD student, I was like, what am I doing here? Why did they hire me? I don't know what I'm doing. But when you see your PhD advisor, who is a genius, get rejected over and over again, and she was always pretty positive about it, you kind of just learn to not take it personally. It's just the way the game works. I've seen the same proposals get funded and not get funded. It's also the peer review. It tries to be as objective as possible, but it's always going to be subjective in some way. And once you kind of get used to it, it's okay. But definitely when I started, getting all these rejections was very unusual for me. But you kind of see everyone around you doing it, and you always learn.
I guess over time you kind of grow resilient to it. You're almost like a superhuman. You could fail at anything and you'll be fine.
Yeah. And there is always something. Or just a human. Exactly. There used to be a little science gallery in Trinity when I was there, and they had this amazing exhibition on fail again, fail better. And it was just all of these inventions that were terrible and just like never worked. They were all just in this museum, and then like what they inspired though, which normally did end up working. So there is always like, we take many steps as we're trying to get towards some goal, but most of the steps you take are likely to be in the wrong direction. But you've got to take them and figure it out.
Got a few questions from a listener now. That listener is Rosario S. Apart from universities and museums, what other companies could you look at for studying a PhD or other academic careers?
As I'm based in the US right now, I probably know a little bit more about the US, but there will be similar organizations around the UK, Ireland, and Europe, which I'll try and remember as I go. But I guess for me, I work in astrophysics. My first thought would be somewhere like NASA, where you can either just get it, an internship as an undergraduate student, or you can also do a PhD there. You might be linked in some way to a university, but your day-to-day would be at one of these NASA institutes working with research scientists on a problem. And then also, if you work at NASA, you will probably be helping out with one of the missions. Like you might be helping out scheduling observations with one of these telescopes in space, or maybe like helping with the logistics of a launch or something like that. Then I'm thinking in Europe, I guess the partner organization to NASA would be ESA, which is the European Space Agency. And they'll have loads of internships for undergrads as well, that you can definitely do a PhD, at least linked to one of the ESA centers. And ESO is the European Southern Observatory. I'd say they have lots of opportunities, and they definitely have PhDs too.
I mean, I didn't even know you could do a PhD not at a uni. So that's super interesting. Ritiga's second question, which also we kind of have touched on, is studying a PhD only suitable for those that are financially stable? How can you get financial support during your PhD?
Especially a science PhD, they are generally all funded. I know in the UK, a lot of astronomy PhDs are funded by the STFC, which is the Science and Technology something council. Maybe Anne-Marie,
I should really know what it stands for. I think it's facilities. Yeah, Facilities Council.
So they will fund a lot of PhDs all over the UK. On top of that, lots of different universities will have their own funding. So since I wasn't a UK student, I had to get funding directly from the university. And that covered, my stipend for 4 years. All of that gave me I had a fund to travel every year. I could go to a conference every summer. And that pays you a stipend that's set. It's not a very high number. And the reason is because, as the cost of living rises and rises year on year, these organizations can be quite slow to be like, oh yeah, the PhD students need a raise. But what I found at Edinburgh anyway was that I also did a lot of teaching on top of my PhD. And that was like a really nice way to supplement my income as well. So like that is actually paid very well because, you've done undergrad. You're a great person to go into undergrads and help them do whatever course they're doing.
Thank you so much for today, Johanna. Where can our listeners find out more about you and the work that you do?
Well, thank you for having me. If anyone wants to see what I'm up to, you can follow me on Twitter at Johanna M. Vos, or you can look at my website, which is johannavos.github.io.
You've been listening to Stemettes Say What, a podcast brought to you by Stemettes. To find out more about Stemettes, visit stemettes.org. That's STEMETTES.org. Or you can find us on Twitter, Instagram, TikTok, LinkedIn, and YouTube via the handle, you guessed it, Stemettes.
And don't forget to subscribe to the show so you'll get the latest episode of Stemettes Say What in your feed as soon as it's released. And while you're there, leave us a review and let us know what you thought.
I'm Carla Rosario.
And I'm Anne-Marie Imafidon. Bye for now.
This podcast is produced by Unedited.